Lecture 9, Part 4. We just went through a conditional proof in detail, this one on the board. I was stressing that you can, that the big advantage of conditional proof is that the conclusion, right, tells you what to assume, and also what goes here. The consequent of the conditional you're trying to prove is the specific formula that will end your subproof. So that when you set up for the subproof, the order in which your theses, your formulas appear, right, this one and this one, it's always the beginning and the end of the subproof appear first, okay? And the particular formulas that appear are determined by the structure of the conclusion you're trying to prove, okay? And I mentioned that if you can apply that rule, it makes proofs that require embedded subproofs, subproofs within subproofs, makes them much easier. So let me just look at this one. I'm going to do the indirect proof over here from page 181 in a minute, but let me show you this from page 180. This is still in the section of conditional proof. It ends a section of conditional proof. But look at how this goes. So you've got a subproof within a subproof here, right? So you've got a conditional, one premise, it is a conditional with a conditional as a consequent, but you've got this conclusion here, and it's the structure of the conclusion, right? You look at the conclusion and you say, okay, what is this? What's its form? It is a conditional. What? Okay, and you just say, it's the structure of this conditional, right? What its antecedent is and what its consequent is. That tells you what you assume and the formula you'll have to end the subproof. So the first things that appear here on your proof are step 2, which you'll notice is the antecedent of the conditional that is your conclusion, right? The thing you're trying to prove. You're not looking at the structure of your premise at all, right? That's what you're trying to prove. So none of this is here. You got the premise written down, 1. You got the conclusion at the bottom. How do I get there? Okay, it's a conditional. I'm going to assume the antecedent, that's that, and put the consequent down the bottom. So the things that appear, first 1 and 9, of course, the premise and the conclusion. Next things that appear are 2 and 8, right? Premise, the formula for 2 appears, you write that line and you end it in 8. That's the last line on the subformula. How do I know it's in particular A hook C? That is the consequent of my conditional, all right? And now when I've got that on the board, okay, what do? I repeat, I return to my mantra. Look at the structure of my conclusion, right? Look at my conclusion. What is it? It is a conditional. Because it is a conditional, I'm setting up for another conditional proof, right? It is a conditional, okay? And what is its antecedent? In particular, it's A. So I'm going to assume A, right? Within this subformula, within this main subformula, I'm assuming A, and I put C down the bottom. So the next formulas that appear are 3 and 7. The A appears and the C appears. C is the consequent of this particular conditional. And when I have derived that, then I know that I finished that subproof and that I'm allowed to infer A hook C. Not quite on the main line, but on the line it's epistemologically equivalent to the first assumption, right? It's on the same line as the first assumption. Given the premise, assuming this first assumption, A hook C is absolutely true if these steps are all justified steps, right? And if that's true, then it's true that if not B, hook not A, then A hook C is true, which is exactly the conclusion. Sorry, I hope that's focused. All right, so that's what appears first. So that's the notice how the geometry of the proof comes into view, right? First, step 1 and 9, that's what you write down, the premise, the conclusion, and then 2 and 8, right? And then you look at 8, you look at your conclusion, and that gives you 3 and 7, right? So these things all come out, and these formulas in particular, right, 8 and 7 here, they are put there, those particular formulas are put there, given that these are consequence of the conclusions you need to derive. Right? It's A hook C because the end of the subproof, the main subproof, will be achieved when you get the specific consequent of that conditional. That's a conditional, right? So you're assuming A, and you're putting C in particular right here. And now it's just a matter of deriving these 3 formulas, right? So all the new stuff is getting all those formulas. And then it's just a matter of, right, you've got A, so you can modus ponens to B hooks. What do they do here? They contrap on 2 to get A hook B, and do a modus ponens. All right, another modus ponens, easy to get C. All those steps are pretty easy. Okay? So all the new stuff is just being attentive, knowing where to look, looking at your conclusion, and letting it determine for conditionals, just knowing that you're assuming the antecedent, your last step of the subproof is the consequent. That's what you're allows you to infer that particular conditional. All right, so let's look at indirect proof. Across a bit. So as I say, this is page 181, the next page, the first example for indirect proof in the section on indirect proof. So you've got these 3 premises. These are all prem. You are tasked with deriving not n. So remember, you will be given things to prove, right? You'll be given a list of premises and a conclusion. You are not given any hint about what rules are going to be useful, right? So part of the test, part of the exam, is you knowing when you should use conditional proof, when you should use indirect proof, and whether you should use either of those, or whether you should just use the rules of inference and replacement rules, like the proofs you've been doing up to now. When is it useful to use indirect proof? Well, if we look back to the form of indirect proof, back here, right, the conclusion of an indirect proof is a negation. What is the form of the conclusion? It is a negation, always, right? You're only legitimately, correctly using indirect proof if the thing you've derived is a negation. It can be any negation, right? But the major operator has to be a negation. Form of the conclusion for indirect proof is always not P, which means, right, P is a centennial variable, so it can be any formula at all, but it has to be that the major operator of the overall thing is a negation, right? It has to be not P. So it can't be a conditional, can't be a disjunction, can't be a conjunction, blah, blah, blah. It has to be a negation, right? So when you look at this, what do? Remain conclusion driven, right? That's your mantra. Look at the structure of your conclusion. Ask, what is the structure? That's equivalent to the question. What is the major operator of this? I've repeated all this stuff 100 times, but having graded your quizzes, you guys didn't know to do this, right? You clearly weren't looking at the structure of your conclusion. You weren't looking at your conclusion, asking what its structure is, and thinking the 2 thoughts that I've been saying for the whole section on proofs that you have to be thinking. Namely, what rule is going to get me to a conclusion of that structure? And secondly, what formulas do I need to derive in order to apply that rule to get home to the conclusion? All right? But let's apply that thought here. What is the form of my conclusion? It's a negation, right? Oh, okay, good chance indirect proof is going to be useful here, right? And even if it is the case that, I mean, you've proved, you've done proofs before today, right, in units 7 and 8, that did prove negations using just modus ponens and modus tollens and destructive syllogism and so on. So it might be the case that it's not necessary to use indirect proof, but nonetheless, even if you can quite easily get this from your normal rules, it's not going to make it harder to set up for an indirect proof. So it's probably not going to lead you astray to set up for indirect proof. Anyway, this is you've got a negation here, so perfect. Looks like a paradigm case, a typical example where indirect proof will be useful. Why? Conclusion is a negation, right? So let me just go ahead and set up for indirect proof, right? So I'm going to have a sub-formula. This, notice I'm putting the end of my subproof right before this formula, which I can do because, right, this is going to be an indirect proof and the conclusion is going to be not n, which is a formula in the form not p. It's in the correct form for the conclusion of indirect proof. Right, so my justification, I'm anticipating, is going to be indirect proof. Right? Now, notice here the big structural difference between conditional proof and indirect proof. Right. I have these three premises. Oh, I do write my assumption down, right? Okay, so a second until that. The big crucial step is knowing what the assumption is, right? How do I correctly apply indirect proof? If I assume P, I can derive not P. Well, my not P is not N, so my P is just N, right? This is indirect proof / reductio ad absurdum, right? What am I doing? I'm assuming N. If I can derive something absurd, if I can derive a contradiction, then I'm allowed to discharge the assumption and infer as true my main line, right, where things are just as true as the premises, that not P is true, okay? Okay, now comes the big structural difference between indirect proof and conditional proof. In conditional proof, you have the big advantage that, right, you're inferring a conditional, and you had the big advantage that when you set up your subproof, you can write down at the end of your subproof the specific formula which when you arrive at, when you deduce, when you infer as a justified step, when you get to that, you could, conditional proof, the big advantage is you can write down, just setting up the subproof, you put the A at the top, and the consequent of the conditional you're trying to prove at the end. So you're given the specific formula, which when you derive, you know you're done with the subproof, and you're discharging the assumption and getting back to the main line, right? You don't have quite that advantage with indirect proof, okay? Because the form again was assuming P, derive any contradiction, anything in the form Q and not Q, right? And you can infer not P. But you don't know what Q is. You don't know what contradiction exactly you're going to derive, right? Or more specifically, you don't know what conclusion what contradiction you'll be able to get. You don't know what specific formula you'll be able to get. You don't know which specific formula you'll be able to get both it and its contradiction. You don't know that, right? That's not given to you by the structure of your conclusion. This is a negation, right? If I can derive any contradiction, I'm allowed to infer not P. But what I don't have here is, say, a conditional with a consequent where the consequent goes here. I don't have